The idea of building factories up in orbit, creating these perfect, flawless materials in zero-G, for decades that sounded like something straight out of science fiction. But what's really wild is that this far-off dream is actually starting to happen. So, let's get into it and explore how manufacturing in space could seriously be the beginning of a whole new industrial revolution.
And get this, the ambition to industrialize space is not new at all. This right here is the cover of a report that NASA commissioned all the way back in 1978. Can you believe that? For almost 50 years, scientists and engineers have been laying the groundwork, dreaming about taking our industries off the planet.
So, what was that original vision? What were the pioneers of this whole idea really hoping to accomplish by building stuff up in the cosmos?
And this quote just nails it. The core promise, right from the very beginning, wasn't about escaping Earth. The whole point was to use the unique conditions of space, the vacuum, the radiation, and especially the lack of gravity, to solve real problems and create real value for everyone right back here on the ground. Okay, so that brings us to the really cool science behind all of this. I mean, why would you go through all the trouble and, let's be honest, the incredible expense of building a factory 250 miles straight up? Well, the answer comes down to one key concept: microgravity.
Now, it's not really zero gravity. Gravity's still there. It's more like you're in a constant state of free fall. And this environment, where everything is pretty much weightless, gets rid of forces that cause huge problems for high-precision manufacturing down here on Earth. Basically, microgravity creates an almost perfect laboratory, totally free from the physical limits we have to deal with every day.
And this just lays out the difference perfectly. See, on Earth, gravity is this constant troublemaker. It makes heavier materials sink, that's called sedimentation, and it creates these little swirls and currents in fluids, which is convection. Those forces create tiny, tiny defects in everything from metal alloys to crystals. But up in space, none of that. It's gone. So you can get perfectly uniform mixtures, you can grow flawless crystals, and you can create materials that aren't stressed out by their own weight. It's a game changer.
And this isn't just a theory, Right now, aboard the International Space Station, researchers are already putting microgravity to work. So what exactly are we making up there?
The potential applications are just incredible. For our internet, there's something called ZB-LAN fiber optics, a material so pure it could make today's internet speeds feel like old-school dial-up. For airplanes and energy, we can create flawless superalloys that are stronger and lighter than anything we can make on Earth. And for medicine, wow, the potential is revolutionary. We're talking about growing perfect protein crystals to design brand new drugs, and even 3D bioprinting human tissue that doesn't collapse under its own weight. And listen, this isn't some sci-fi projection for the year 2050. The pharmaceutical giant Merck is actively using the ISS right now. They're working on a new formulation of their blockbuster cancer drug, Keytruda. They're studying how it crystallizes in microgravity to figure out how to improve its delivery and make it more effective for patients back here on Earth. It's amazing.
Okay, so it all sounds great, but of course, building an entire economy in orbit is, well, it's not going to be easy. The potential is absolutely immense, but so are the challenges. We are literally facing some of the most complex engineering problems ever.
One of the biggest hurdles is just control. For these factories to actually work, they have to be almost completely autonomous. To really get why, just look at the extreme case, Mars. The round-trip communication delay can be up to 42 minutes. That makes real-time control totally impossible. Now, the delay to orbit is tiny in comparison, but the principle's the same. These facilities have to be able to run themselves, troubleshoot problems, and even make repairs with almost no help from us.
And even before we launch anything, the work on the ground is just staggering. This graph, it shows a simulation for just one small part of a 3D printing process. Running these super complex digital twins to predict how materials are going to behave in space takes an insane amount of computing power. We're talking hours, sometimes even days on supercomputers.
And as we push out into this new frontier, we have to be smart and avoid repeating old mistakes. Every single launch risks creating more space junk, turning the area around Earth into a dangerous minefield. There are real concerns about pollution from rockets, and then there's the huge legal question looming over everything: who owns what in space? The Outer Space Treaty from 1967 was written for countries, not for private companies, which leaves this huge legal gray area that we're still trying to figure out.
But even with all those hurdles, the momentum is it's undeniable. A whole new economy is starting to take shape in what's called low Earth orbit, or LEO, and its potential impact is absolutely massive. Yeah, the money is finally starting to make sense. Right now, in-space manufacturing is already a market worth close to $4 billion. But that's not the important part. The key is where it's headed. Projections show it more than doubling to $10 billion by 2030. That's explosive growth. It's a clear signal that we're moving from just doing experiments to building a real industry.
And some of the biggest players in this new space race, they have an even bigger vision. Jeff Bezos has talked about a future where we move all the heavy, polluting industries completely off-world and just run them in space. This would preserve Earth as a place for people and light industry. I mean, it's a radical idea, for sure, but it really shows you the scale of thinking that's driving this whole movement.
So it really feels like we're standing at the dawn of a new industrial age. The hurdles, technical, financial, and ethical, they're huge, no doubt about it. But the pull of creating revolutionary medicines, developing impossible new technologies, all while maybe easing the industrial burden on our planet, that's proving to be irresistible. Humanity is looking up. So the only question left is, are we about to watch the next industrial revolution happen just a few hundred miles above our heads?